guys, we are going to work in our notes with linear relationships. So this should be somewhere around page 444, 443, 442. It says right here it was 444. So look to see if you can find this in your book if you do not have a copy of the notes. Okay? So this says determine whether the relationship in each table represents a linear relationship. If it represents a linear relationship, then we can write an equation for it. Okay? So remember, if it's linear, it will have a constant rate of change. And remember, constant rate of change is always m. M is slope. Okay? Same thing. All those things mean the same thing. M is constant rate of change. M is slope. M means it might be proportional, it might not. Okay? So, first of all, let's see if it's linear. So if it's linear, it's going to have a constant rate of change. So, what do you get for delta y? I'm going to stop a second. What I see is this goes down by 4, right? 20 take away 4 is 16. Or you can say 20 take away 16 is 4, but it's going down, so it has to be minus. Okay? 16 take away 12 is 4. 12 take away 8 is 4. Okay? So my delta y, I'm going to move this over a little. My delta y is negative 4. Okay? And then here, we change by 5. Okay? So we do have a constant rate of change, right? So guys, this is linear. Why is it linear? Because it has a constant rate of change. This means we can write an equation for it. In 7th grade, you can write an equation for proportional and linear non-proportional, okay? So let's see if it's proportional. We will take it back to see if it goes through 0, 0. Oh, but I don't have to, look. It's already there, okay? So the one thing you can probably tell me is this is not proportional, right? It doesn't go through 0, 0. So that means we cannot use y equals kx. This is not k. It is only m. Negative 4 over 5 is m. So we would say y equals m x plus b. And the only ones we need to fill in are m and b. So y equals m, here it is, negative 4/5, x plus, and I'm looking over here to make sure it's positive, and it is, plus 20. There is our equation. This right here is always b. It's the y-intercept. Remember, I've shown y'all before, that would mean on a line I would have to take this up to 20. This would be 20 here. And our line would go through. It actually would probably be a little bit more slanted. Okay? Ooh, and I haven't taught this to you guys. If your slope is negative, it's actually going to go down. So if your constant rate of change is negative, your line's going to go down. Okay? So just a few things I know about this line. Now, B, I can already see here we go through 0, 0, right? But we have to make sure we have a constant rate of change. Delta y over delta x. Okay? So, how much do we have here? So it looks like this one is plus 2. 0 plus 2 is 2. 2 plus what is 8? 2 plus 6. 8 plus what is 18? 10. Now, I know these are not the same. However, we cannot say for sure until we simplify it down or until we compare two of them. Okay, so delta x, 0 to 2 is 2. Okay, so 2 divided by 2 is 1, right? That's 2. And 6 divided by 2 is 3. So you know what? This is not linear. Therefore, it is not proportional. Okay? Not linear, not proportional. We cannot right now write an equation for this one. We have not learned how to write one for this. Okay? So you don't even have to worry about that this year. You need to know only ones that are linear. Okay, so now, without even doing anything here, I can tell this is proportional. Straight line. It looks like it goes through 0, 0 anyway. Surrey ordered running shoes for the cross-country team online. Each shirt cost $15 plus $4 shipping for each item. Use a graph to determine if the relationship between the total cost and the number of shirts sold is a linear relationship. So I'm going to have to kind of double check this because it looks proportional, but it also looks like it could be a little bit above that. So I'm going to check, but to me, we'll just have to check. So based on this, what I'm seeing, this looks proportional to me. I'm just going to tell you. So each shirt costs $15 plus $4 shipping, okay, for each item. So this time it's saying $4 for each item, guys. That means we have to pay that amount for each one, okay? So one shirt is $15 plus I have to pay $4 for each item. The way I am reading that, okay, which is not, we don't always do that, sometimes we do. Unlike our pizza delivery problem, okay, so 19, so 19 times 2, 2 times 1 is 2 plus 1 is 3, 38. Now 3 shirts, 19 times 3. Or you can add 38 plus 19 if you don't like multiplying. If you add this, you can check your answer with me down here. 3 times 9, 27. Carry the 2. 3 times 1 is 3 plus 2 is 5. 57. And then 19 times 4. As a teacher, I'm just going to tell you, I love seeing all this work on your paper. 4 times 9. 36, carry the 3, 4 times 1 is 4, plus 3 is 7, 76. So, when I look, 1, 19, 2, this looks like it's graphed correctly, 38, 3, 57, and 4, 76. This looks like it's graphed correctly. So, I think it's proportional, I think, based on how it looks. So hopefully you know that each time we increased by 19, right? For every shirt. So we do have a constant rate of change. Delta Y is what? 19. Delta X is 1. So remember, this is always M, sometimes K. Let's see if it's K. In order for it to be K, since we already have a constant rate of change, what's our other reason? Has to go through 0, 0. So here, 4, 3, 2, 1, 0. And then each time we're subtracting 19, right? So 19 minus 19 is 0. So we do have a direct variation, which means that it is proportional. Make sure you know that. Direct variation, which is K, Y over X, that's that constant ratio. Okay, so we have a proportional relationship. That means we use Y equals KX. Do I know what K is? I sure do. It's M in this case, right? We said it's always M, sometimes K. If it's K, it happens to be both. Okay? So we have K, which is 19x. There we go. That's our proportional equation. No plus, no minus. Okay? So let's look at the next one. Determine whether the relationship in each table represents a linear relationship. Okay? Now this can be kind of hard here. Okay? We mess up a lot of time with our integers. From -1 to 0, it's getting bigger, right? By 1. From 0 to 1, 1. From 1 to 2, 1. Delta y is 1. From here, from -2 to 0, it's getting bigger because it's going from a negative to a positive 2. 0 to 2 is a positive 2. 2 to 4 is a positive 2. So the change in x is 2. So do we have a constant rate of change? Yes. So this says, is it linear? We would say, and I'm going to erase this so we can say, yes, this is linear because it has a constant rate of change. Hopefully you can write smaller than me. Now, if I was to say, is it proportional? You would say, yes, because look what it goes through. 0, 0. It has a constant rate of change, and it goes through 0, 0. So it's y. This is not part of the problem. Y equals kx. Okay? And k was a half. Half was also m, right? But since it's proportional, we just plug that constant rate of change, which also would be your constant proportionality, back in here. Okay? Let's try this one. Delta y, delta x. So how much is it from here to here? 3. How about from here to here? Isn't that 5? How about from here to here? Well, that's 7. So I have a 3, a 5, and a 7. Here to here, 1. Here to here, 1. Here to here, 1. Delta x, guys, I can already tell we do not have a constant rate of change. So this cannot be proportional, and it's not linear. Okay? There's no constant rate of change. This is not linear because there is no constant rate of change. Okay, and remember, we cannot do an equation for this. We can only do an equation if it's linear. If you need to pause the video, pause the video. Last one. Here to here, here to here, here to here. 13 plus what is 28? Or 28 minus 13. Do that. 28 to 43. I'm just going to tell you for the sake of time. If you subtract it, you'll get 15. If I add 43 plus 15, I get 58. So delta y is 15. Delta x, 5, 5, 5. So delta x is 5. Sorry, I'm going fast. Pause if you need to. 15 divided by 5 is 3, or we could do 3 over 1. So this is linear. Okay, if I wanted to write an equation, y equals, well, I haven't even checked to see if it's proportional. But we can check by taking our table back, right? Running out of time. See if you can figure out